What's going on, everybody? It's your boy Kilo Loco, and today we're going to be covering protocols in Swift. We're going to be going over how to use them, with both structs and classes, and why they're so powerful, and why you definitely need to get on to this protocol-oriented level, man. All right, so we're going to just be going over the basics today. So if you have ever had a trouble understanding how protocols work, we're gonna cover it right here for you. We're gonna do it for you. We're gonna do it for you. All right, so let's get into it. All right, so the example that I'm going to give you today is going to be mainly based off of the idea like if we were going to be building an app, and we're going to be covering is going to be done in playgrounds. But the way that I kind of want you to idealize this is if you're into cryptocurrency, then it'd be kind of like us building an app that would display our exchanges, right? So if you think about it like this, what you would do is you would have a table view essentially that has all the different cryptocurrencies. That's all you really need to know. Even if you don't know cryptocurrency, just understand you would have a table view, which each cell having something different in it. And each of those items might be a different type of object. Maybe one's a struct, the other one's a class, the next one's a enum or something like that, and you just want to show all that data in the same table view, but they're all different objects. Well, how do you do that? Because now you're working with classes, you're working with structs, you're working with enums, and one of the possible solutions to fixing that problem would be to create a protocol that each of those conforms to, so that you can display all those different types of objects in the same table view. So let's get into it right now. All right, so the first thing that I want to do is I want to create an actual protocol. And the protocol that we're going to be using today is a cryptocurrency. And some of the things that go into a cryptocurrency would be every cryptocurrency has a name and every cryptocurrency has a price. So those are two of the things that we want in our protocol. So let's go ahead and build that out real quick, and then we're going to go over what each of these things mean. All right, so now we have our cryptocurrency protocol, and a protocol you could kind of think of. I've heard it be used kind of like a blueprint. You could describe it kind of like a blueprint, and essentially what a protocol means is that there are a certain set of instructions that your object has to abide by. So any object that conforms to cryptocurrency has to have a name and it has to have a price. Hell, if we even deleted all this stuff, if we wanted to say, you know what, it doesn't need to have any variables specific, it doesn't need to say name, it doesn't need to say price, we could just leave it like this if we wanted to. But for this example, we're going to actually give it some properties that each object has to conform to. But just keep that in mind, that you could group together objects by just saying right here cryptocurrency. You could just essentially, it's kind of like tagging. It's like hashtag cryptocurrency up on here, and now we're looking for anything that's hashtag cryptocurrency up on here. I mean, don't put the hash or don't put the pound sign there. I'm just saying, hashtag, whatever. Now, if we want to create an object that conforms to a cryptocurrency, what we need to do is we need to make sure that it has name and price. So let's go ahead and build out Bitcoin, which we can make as a struct, and then we can make Ethereum, and we'll do a class. All right, so far we just have two objects that we could technically initialize, since they don't have any properties or anything like that, if we wanted. And right now they don't conform to cryptocurrency, but watch, this is the reason I didn't actually put in the name and the price, is because I wanted to show you, in case you didn't know, is if you make it conform to cryptocurrency right here, what Xcode will do for you is it'll say, hey, you need to stop messing around, because you know damn well that it doesn't conform to cryptocurrency. Let's drop some of these things that make it conform into the actual object that you're trying to make conform to cryptocurrency. So if you just click on the red stop sign, you say fix, bam, drops them in there, just like that. Now, the next thing that I wanted to talk about, now that we're actually making Ethereum conform to cryptocurrency, and now that they're both conforming to cryptocurrency, what I wanted to go back over is, as you can see up here, name is a get and price is a get set. Now this part can be a little bit confusing, but all it's saying is that get, if it's just get, then it can essentially do anything that you would normally do to a property. You can make it a variable, you can make it a constant, you can make it a computed property, you can do all the things to it, right? But if you do get set actually limits it, even though it kind of looks like it would be giving you more functionality and flexibility. It actually limits you, because what you wouldn't be able to do is have a constant, right? So you wouldn't be able to have a constant price because it's get set. You can't set a constant. So like if we were to even try, and what we have to do for Ethereum, we have to fix it. Let's fix it real quick. Yeah, it's been a bad day for cryptocurrency. Huge dips today. All right, so as you can see, it has a name and a price, so we're good on Ethereum. But going back, what we could do is, if we want it, we could make Bitcoin have the name as a constant, which would make sense, right? Because essentially, you're not going to be changing the name. Once the name is set for a cryptocurrency, it's going to stay that for its lifetime. So it makes sense. And the reason why we can do that is because it's get, but it's also get. Once again, get gives you more flexibility to do whatever you want with your object. Now, if we were to try to make price a constant by doing let, once again, it's settable. Therefore, we cannot do this, and it'll actually say that it does not conform to the cryptocurrency. So that's something very important to keep in mind. All right, so before we move any further, the next thing that I want to do is I want to show you that an enum can actually conform to a protocol. Let's fix Bitcoin real quick and turn the price back into a var. And I just want to show you that, yes, you can use enums right here. I don't personally know a use case where you would want to use both enums with classes or with structs in the same instance, but just so you know, they could technically be done. So like if we wanted to do an enum, what we could do is we could say Litecoin would be an enum, and what we would do is we would just say it's going to conform to cryptocurrency, and then once again, all it's going to do is it's going to give us the compile error saying that, hey, you know what, it doesn't conform, you need to fix this. And then enums actually can't have stored values. So what you need to do is you would actually need to make it a computed property and have it return something like LTC, right? And then for the price, once again, return, what is it today? It's like 150, sadly. Yeah, been a bad day for crypto. Oh, and that reminds me, with the get and set, when you specify it for computed properties, you do have to implement both of them if it says get and set inside the actual protocol. So since we have get and set for price, we actually have to implement both get and set for price if we're doing a computed property. So let's do that. We would do get, and we would just return, it's like 150 right now, something like that, really low. And then set, it would be like whatever we're setting to one of the stored properties or something like that. So just keep that in mind. Now, we're not going to be working with Ethereum. Once again, it's kind of like with Litecoin, because it's the enum, and who cares about Litecoin? Nah. But no, seriously, like it doesn't really make that much sense to be working with enum for the use cases that we're going to cover. So the next thing that I want to go over with you guys is are the functions and the methods that you can actually implement in a protocol. You can say that it has to have certain methods inside of it. So what we can do is we can say, okay, well, one of the methods that we would have inside of a cryptocurrency would be to show the history of that cryptocurrency, right? Maybe we just want to see the history. So we would declare that it needs to have some type of function by just putting the signature in here. We wouldn't actually have implementation. You can't do implementation directly from the protocol layout, like how it is right here. You can't do implementation right here. That's in extensions. We'll cover that in a later video. But yeah, just know that this is how you would define a method in a protocol. So now we have to go back and fix both Bitcoin and Ethereum. All right, so as we can see, we implemented the both methods that were required, or the method that was required on both of the objects. And as you can see, we implemented different functionality for both. they're both doing print, but we obviously can put in different functionality for both. This one's just printing BTC history. This one's printing ETH history, right? So just keep that in mind. It's kind of like overriding a class when you subclass, right? So it's saying you still have that method available to you. I mean, you have to call it and implement the functionality yourself, but it's kind of similar in that sense that the protocol has all the methods that you're going to need to implement, and then you could put different functionality in each of those methods. The other thing that I wanted to show you is mutating, because when you have these objects, if you have something that's causing one of the properties to change on the actual object, well, then you need to actually specify in the protocol that it is a mutating function. So let's do that right now. All right, so we added transfer as one of the functions or the methods that would have to be implemented by anything that's a cryptocurrency, right? And we're specifying with the keyword that it's mutating. So now when we actually implement it on a struct, we have to specify that, hey, it is mutating. We have to specify that. And we would just say func transfer, right? And then we would just do our implementation here. It would just be like a transferring bit, right? Or BTC, right? So that makes our Bitcoin conform. But when we go over here on classes, when we do something that's mutating, since it's a class and it's not a value type and it's not creating a copy, it's just changing something that's pointing, it's just changing the object that it's referencing in memory. We don't actually have to specify the mutating keyword on the function. So we could just say transfer like this, if I know how to spell, not fern, func, not ferk, func, transfer, and then we would just say, print, and we're just transferring the ETH, right? Whatever that spells. So just keep that in mind. Once again, since this is a value type struct, you do have to specify the mutating keyword. Classes, you don't have to specify the mutating keyword. Very important to understand that. Now, the very last thing that you want to keep in mind is that you can also have initializers that are part of your protocol. So it would actually have each of these objects would have to have some type of initializer in order for it to conform to a protocol. So let's implement that right now. All right, so as you can see, I added an initializer that says name. You have to, in order to create an actual cryptocurrency object, you need to give me a name before I can actually put it onto my list of cryptocurrencies that we have in our table view or something like that, right? So what we would need is to actually pass in a name in order to create a Bitcoin, and we would need to pass in a name to create an Ethereum, right? So we pass it in, we just say self.name is equal to name, usual initializer for struct, value type, it's fine. But with class, what you can see here is we're doing the exact same thing, but what we actually have to do is we have to say required, because this has to be implemented. Now you can have other initializers in there. You can have other convenience initializers, anything like that. But what you do have to say, you have to specify that this is one of the required initializers that have to be part of that object in order for it to conform to cryptocurrency fully as a class only. And we're getting an error right here just because we didn't set price. So we'll just say price is equal, what was it today? It was below 10,000 today. So it was like 10,000. That was awesome. All right, so that's the last thing that you really need to know in the different types of things that you would generally put inside of a protocol. And this is kind of the layout. So once again, variables, you always have to specify whether it's a get or a get set. The price or so one. All right, so that's pretty much all you really need to know about the layout of a protocol. You just have the name, And then if your protocol actually conforms to anything, then you can specify it like my other protocol, because then your protocol could conform to that protocol, or it could just be a combination of other protocols. But we're gonna go over that in a different video. But yeah, going back, you specify properties this way with the get or a get set, and then functions you specify just with the function signature, but not the implementation. If it's mutating, make sure you add the mutating, or else it won't be able to mutate your object, especially for structs. And then you, if you would like, you can also add an initializer, require an initializer. Now that's great, learning how to use functions, all that good stuff. But what is the purpose, once again, what is the purpose of using a protocol? Well, like I said, we have Bitcoin, which is a struct, and Ethereum, which is a class. Now, how do you combine those two into one array that can display into a table view? If you wanted to do in a table view or collection view or whatever you wanted to do, how do we combine those objects into one? Well, what we do is we just create an array of cryptocurrencies. Instead of having an array of Bitcoin or an array of Ethereum, we would just have an array of cryptocurrencies. So let's do that right now. All right, so as you can see, what I did was I initialized a Bitcoin, I initialized an Ethereum, right? And then what I did was I made cryptocurrencies of type an array of cryptocurrency, and then I just put both of those objects in there. Now we could have done it like this. We could have made it an empty array like so. Well, not like so. It would be cryptocurrency, not just an empty array of nothingness. I can't do that, Kyle. But what we could have done cryptocurrencies, and maybe we're getting them at a later time, and what we would do was just do append new element, and then we would just append our BTC. We would do cryptocurrencies dot append our new element ETH. And now what we'll do is we'll just print out the cryptocurrencies, and what it'll do is it'll show us the two cryptocurrencies that we have in there. Oh, well, you can't have a let and then try to append to it, right? So let's change that to a var. Come on, Kyle, get it together. All right, so what we're gonna do is we're just gonna append those two and then print them out. So let's go ahead and run that. And as we can kind of see, what we have are our objects. So we have Bitcoin, which is a little bit easier to read because it's a struct, so it's going to lay things out quite nicely for us. And then we have our Ethereum object in there as well, which it's not going to show because it's technically a pointer. So yeah, but if we were to do a for each, or if we were to do a loop over each of these objects, or if I were to just say cryptocurrencies dot first, we want the first, or we could just do at the 0 index, and then we say we have access to both the name and the price. And the reason for that, and we have show history and transfer, and the reason for that is because we don't know what these objects are. We don't know if it's Bitcoin, Ethereum, we don't know if it's Litecoin, Cardano, we don't know anything else about any of the other objects in the array. We don't know what other properties that they have. But what we do know is that they conform to cryptocurrency, which means that we technically have access to all of these objects or all of these members, all of the properties and all of the methods. So that's very important. That's the true power behind using protocols in this sense. So what we could do is we could just say name, and then when we run that, you'll see that the actual name will be BTC over here because it's going to be the first object that's in that array. So we appended BTC, we appended Bitcoin, we appended Ethereum, and now we're actually going to have the name of the first object in there, which is Bitcoin. Man, I really hate the Xcode simulator, the playgrounds. Sometimes it just crashes all the time. All right, so as you can see, it printed out BTC over here. So once again, just going back to being able to access any of these properties, cryptocurrencies, and we'll say, 1. So that's going to be the Ethereum, and we're just going to, we're going to transfer, right? We're going to transfer. And when we run that over here, we're going to get a printout over here saying transferring ETH, So that's protocols. That's the getting up and running with it. I hope that you guys kind of see the value of working with protocols. They're very powerful, and we're going to really get into like what the full extent of protocols is. I plan on covering even more than this because protocols can actually get very deep and be very, very powerful, very useful, and then hopefully get you guys up to protocol oriented programming, because I think that's something that most people just aren't able to wrap their head around, and that's why we're starting from the beginning with some of these protocols. So if you found this video helpful, if you learned something new, please make sure that you like this video. If there was something that I was missing or something else that you want to learn, make sure you comment down below. If you're interested in learning more about Swift, then make sure that you subscribe, because I'm putting out all kinds of new content this year. We're going to be upping the amount of content. We're going to be covering, foundational stuff as well as framework type stuff. We're going to be going over like things like Vapor, Firebase, like some of the Google services like the maps and things like that. I'm going to be covering all that stuff this year. So make sure that you subscribe so that you can get more of that content. If you want to reach out to me and have any questions about code, or you're running into a problem, follow me on Twitter. That's probably the best place to reach me if you have a question about code. If you're interested in more of my day-to-day life, follow me on Instagram. I'm going to be posting stuff on my day-to-day life on there. So yeah. Thank you guys for tuning in. It's your boy Kilo Loco, and as always, make sure that you keep coding passionately.